Today we're going to tackle about Marpol Annex 6, a very important topic for maritime industry and global environment. Marpol stands for the International Convention for the Prevention of Pollution from Ships. It's a major international treaty created by the International Maritime Organization. The convention covers a wide range of issues including oil pollution, chemical spills, sewage, and garbage disposals. Why is Marpol Annex 6 important? Well, shipping is a global industry and many ships use heavy fuel oil, which when burned emits large amounts of pollutants. Without regulations like Annex 6, the impact on air quality and the climate would even more severe. Annex 6 was first adopted in 1997, and since then, it has been amended several times to tighten the regulations on air emissions from ships. In today's presentation, we will go over the history and development of Annex 6, its key provisions, how it impacts the shipping industry, and what the future might hold for air pollution regulations. By the end of this presentation, we hope you will have a clearer understanding of why Annex 6 is so important and how it helps protect both the environment and human health.
History and background. Now, let's take a closer look at the history and background of Marpol Annex 6. To understand why Annex 6 was necessary, it's important to look at the context of 1990s. Back then, global shipping was booming and more ships were being built and operated around the world. While this was great for global trade, it also meant that the environmental impact of shipping was growing. One of the biggest concerns at that time was air pollution, particularly the emission of sulfur oxides and nitrogen oxides from ships. These pollutants contribute to acid rain, which damage ecosystem, building, and even crops. They also have serious health effects, especially for living in coastal areas. In response to these growing concerns, the International Maritime Organization, or IMO, adopted Annex 6 in 1997. This was a groundbreaking move because it was the first time that an international agreement is set limits on air pollution from ships.
90% of global trade is carried by sea. Shipping also responsible for airborne oxide of nitrogen, bringing smog and respiratory disease, and sulfur dioxide causing acid rains. It is also responsible for ozone-depleting gases contributing for increasing rate to skin cancer. Emissions are already limited by Marpol regulation in the global fight against pollution and climate change, and IMO is reducing the impact of shipping industries on the quality of air that we breathe. On the 1st of January 2020, the IMO introduced the new global limits of 0.5% fuels from 3.5% sulfur unless the exhaust gas cleaning system is fitted, most commonly known as a scrubber. It has been estimated that 10% of sulfur dioxide emission come from international shipping. Working alongside with ship operator, the International Maritime Organization IMO has introduced a mandatory requirement to reduce greenhouse emission by using exhaust gas control system or scrubber system. The scrubber system can be used to remove particles and neutralize gaseous impurities from combustion exhaust gases, especially acid gases. The following are the locations of main equipment for scrubber system. The scrubber tower are located in a tunnel site. Sea chest and process pump, normally located engine room, low flooring. During the scrubber operation, Marine Road Preventive System (MGPS) is in operation to protect scrubber piping and equipment from marine growth. During the installation, take note of the direction of differential pressure type flow meter for inlet and for the distribution. Take note of the following: the flow direction of strainer, suction and delivery side of process pump and rotation of motor, flow direction of water check valve, liners for process pump must be welded after adjustment of pump and pipes. For process pump and strainer, apply high tensile stud bolts and double nuts. For adjustable pipes, weld and apply coating after adjustment on site. During scrubber operation, sampling for seawater is pumped by water monitoring pump unit to water monitoring cabinet. It will measure pH, turbidity, pH, and temperature of seawater. Suction of seawater is from new seizes. It will flow to strainer, to process pump, to water check valve. And it goes to scrubber tower. Then, the seawater is pumped to scrubber tower. During the scrubbing process, sulfur oxide or SOx and harmful gases are neutralized and mixed with seawater. Clean exhaust gas passes through the exhaust gas duct to the atmosphere. Cleaning of exhaust gas is measured using the Continuous Emission Monitoring System (CEMS) and must be in compliance with IMO and ECA requirement. During the installation of scrubber, be sure to read the maker's manual and maker standard. Scrubber tower must have proper foundations to minimize vibration during operation. If none, install additional support. Exhaust gas pipes, temperature, transmitter must be insulated as per maker standard and shipyard standard. In order to prevent vibration and damage on the expansion joint, apply pipe support as per maker's recommendation. Instrument panel to be mounted just below highest tower inlet pipe as per maker's recommendations. After cleaning exhaust gas with seawater, it will drain to overboard. Be careful with grip pipes installation. Be sure that clamping pipes with lining are installed to prevent vibration and damage. In order to prevent damage on overboard distance piece, pipe thickness check, proper welding check, color check, and special painting check must be implemented. Overboard discharge seawater is continuously monitored by Water Monitoring Unit (WMU) and must be in compliance with United States Coast Guard (USCG) requirement at pH 6. In summary, MGPS treated seawater are pumped from new sieges. Dirt on seawater will be trapped on strainer to protect your process pump. It will flow to scrubber tower to clean the exhaust gas. Mixed seawater and SOx from exhaust gas will be drained to overboard. Exhaust gas cleaning system EGCS will continue pumping, cleaning, and discharge mixed seawater and SOx from exhaust gas.
However, the original Annex 6 was not as strict as it's today. It's only set a global sulfur cap of 4.5% for fuel used by ships, which is much higher than today's limits. Over time, the IMO has made several amendments to Annex 6 to make it more effective. One of the most significant change came in 2008 when the IMO adopted stricter sulfur limits, reducing the global cap to 0.50% by 2020. In addition to regulating sulfur and nitrogen emissions, Annex 6 also introduced new measures to improve the energy efficiency of ships. These measures are critical because the more energy efficient a ship is, the less fuel it burns and fewer emissions it produces. The amendments to Annex 6 reflect the growing global awareness of the need to protect the environment, especially as the effects of climate change become more apparent.
Next, let's explore the key provisions of Marpol Annex 6 in detail. There are four main areas that Annex 6 covers: sulfur oxide emissions, nitrogen oxide emissions, energy efficiency design index, and ship energy efficiency management plan. First, let's talk about sulfur oxide emissions. Ships traditionally used heavy fuel oil, which has a high sulfur content. When burned, this fuel releases large amounts of sulfur dioxide into the atmosphere, contributing to acid rain and air pollution. To combat this, Annex 6 sets strict limits on the sulfur content of marine fuel. The global sulfur cap has been progressively reduced over the years. In 2020, a major milestone was reached when the cap was lowered to 0.50%, down from the previous 3.50%. This means that ships are now required to use much cleaner fuel or install exhaust gas cleaning systems, commonly known as scrubbers. There are also special areas called emission control areas, where even stricter limits apply. In emission control areas, the sulfur content of marine fuel cannot exceed 0.10%. These areas include the Baltic Sea, the North Sea, the North American ECA, and the US Caribbean Sea ECA. Ships operating in these regions must comply with these stricter limits to reduce the environmental impact of shipping. Next, we have nitrogen oxide emissions. Annex 6 introduces limits on nitrogen oxide emissions from ship engines, especially for new ships. These limits are divided into three tiers: Tier 1, Tier 2, and Tier 3, with each tier applying to ships built during specific periods. For example, Tier 3, which is the strictest, applies to ships constructed after 2016 and operating in designated nitrogen oxide emission control areas. Now, let's move on to the Energy Efficiency Design Index, or EEDI. This was introduced to promote energy efficient ship design. All new ships must meet a minimum level of energy efficiency based on their type and size. The EEDI encourages shipbuilders to innovate and design ships that use less fuel and emit fewer pollutants. Finally, we have the Ship Energy Efficiency Management Plan, or SEEMP. Unlike the EEDI, which applies to new ships, the SEEMP applies to all ships. It's a plan that each ship must have to ensure they operate in an energy-efficient manner. This includes measures like optimizing speed, route planning, and maintenance schedules to minimize fuel consumption and emissions. These four key provisions have helped significantly reduce air pollution from ships and promote the use of cleaner, more efficient technologies in the shipping industry.
Okay, now, let's talk about the impact of Marpol Annex 6 in the shipping industry. One of the biggest changes brought about by the Annex 6 is the shift to using cleaner fuels. As we mentioned earlier, the global sulfur cap was lowered to 0.50% in 2020. This means that ships can no longer use high sulfur fuel oil, which was cheaper but much more polluting. Instead, they need to use low sulfur fuel oil or other alternative such as liquefied natural gas or the marine diesel oil. For many ship operations, this has meant higher fuel costs. Low sulfur fuel is more expensive than traditional heavy fuel oil. So this has increased the operational costs for shipping companies. To manage this cost, some ship has installed exhaust gas cleaning system, also known as scrubbers. This device removes sulfur oxides from the ship's exhaust gases and allowing the ship to continue using high sulfur fuel while still complying with the regulations. Okay, another important impact of Annex 6 is the requirements for ship to be more energy efficient. This has led to innovation in ship designs and operation. For example, the Energy Efficiency Design Index encouraged shipbuilders to create more fuel-efficient vessels. In addition the Ship Energy Efficiency Management Plan that requires ships to adopt practices that reduce the fuel consumption, such as optimizing routes and reducing speed. These changes have had a positive impact on the environment, especially in the regions with the high shipping traffic, such as the North Sea and the Baltic Sea, which are designated as the emission control areas. In these areas, the sulfur limit is even stricter at just 0.10%, which had led to noticeable improvements in the air quality. However, the transition has not been easy for everyone. Smaller shipping companies, especially those operating in developed countries, often struggle to keep up with the cost of compliance, like that. While large companies may have the resources to invest in new technologies or cleaner fuels, small operations may find it more difficult to absorb these costs. That's all.
Compliance and enforcement. Let's now take a look at how compliance with Marpol Annex 6 is monitored and enforced. The responsibility for ensuring compliance with Annex 6 falls primarily on two groups: flag states and port states. A flag state is the country in which a ship is registered. Each flag state is responsible for ensuring that the ships flying its flag comply with international regulation, including Marpol Annex 6. This includes issuing certificates to ships that meet the requirements of the convention, conducting inspection, and taking action if a ship is found to be non-compliant. However, the challenge with flag states is that not allow them have the same level resources or commitment to enforcing the rules. Some flag states, especially those with large fleets, are known as flag convenience. These countries may be more lenient in enforcing regulations because they want to attract more ship registrations. This is where port states control comes in. Port states are the countries where ships call, and they have the authority to inspect foreign ships that visit their ports. If a ship is found to be non-compliant with Annex 6, the port state can take a number of actions, including imposing fines, detaining the ship, or even banning it from entering the port in the future. In recent years, enforcing has become stricter, especially in regions with emission control areas. Port authorities in these areas are particularly vigilant in checking that ships are using the correct type of fuel and that they are not exceeding the allowed emissions limit. The introduction of the global sulfur cap in 2020 also led to an increase in fuel testing to ensure that ships are using compliant fuel. Overall, while there are challenges in ensuring global compliance with Annex 6, both flag states and port states play a critical role in enforcing the regulations and ensuring that the ships are doing their part to reduce air pollution.
And for challenges and future developments, as much as Marpol Annex 6 has made a positive impact, it's not without its challenges. One of the biggest hurdles is the cost of compliance, especially for smaller shipping companies or operations in developing countries. Switching to low-sulfur fuels or installing scrubbers requires significant investment. For example, the price difference between regular heavy fuel oil and low-sulfur fuel oil can be quite substantial. In some cases, it can be 50% more expensive. This means higher operating costs for ship owners, which may also lead to higher shipping costs that can trickle down to consumers. Another challenge is the global disparity in enforcement. Not all countries have the same level of resources or political will to enforce Marpol Annex 6 regulations. While countries like the US and the European Union have strict monitoring and heavy penalties for non-compliance, other regions, especially those with limited port state control capabilities, may struggle with enforcement. This creates an uneven playing field where some ships may continue to pollute while avoiding penalties. Despite these challenges, the direction is clear. The future of shipping will involve cleaner technologies and more energy-efficient practices, and Marpol Annex 6 will continue to play a key role in that transition.
Hello friends, in this video we are going to get familiar with Annex 6 of Marpol, which is regulation for the prevention of air pollution from ships. We'll be discussing some important factors causing air pollution from ships and the regulations which have been set to control this pollution and protect the environment. So let's get started. Marpol Annex 6 entered into force on 19th of May 2005. So how is this air pollution caused? The primary and foremost reason of pollution from ships is combustion of fuel. When the fuel burns, it produces exhaust gas, which causes air pollution. This exhaust gas contains substances such as sulfur oxide, nitrogen oxide, carbon monoxide, carbon dioxide, particulate matter, which are all harmful to the marine environment. Also, volatile organic compounds and some ozone depleting substances are released during normal operation of the ship. So there are certain rules and regulations which are given under Annex 6 to control and reduce the emission of these substances. Before discussing them, let me tell you the effects of emission of these substances in the environment. The first adverse effect is acid rain. These substances, when suspended in the air, evaporate with the water vapor and cause acid rain. Acid rain reduces the fertility of the soil, which leads to loss of flora and fauna. it also deteriorates the human health. It causes respiratory issues in humans and also affects the cardiovascular health. Next, it causes ozone depletion. As you all know, ozone layer protects us from harmful UV rays of the sun. Substances like chlorofluorocarbon cause ozone depletion. And last but not the least is global warming. I don't need to explain what global warming is doing to the earth, melting of glaciers, temperature rising, and whatnot. So first, let's discuss about the ozone depleting substances, which is Regulation 12 under Marpol Annex 6. As the name suggests, the ozone depleting substances cause the depletion of ozone layer. Few of the ozone depleting substances you can see here are chlorofluorocarbons, hydrochlorofluorocarbons, and halogens. Chlorofluorocarbons are widely used as coolants in refrigeration and air conditioner systems, and it is found that hydrochlorofluorocarbon have a shorter lifetime than the chlorofluorocarbon, and halogens are gases containing bromine which breaks down ozone in the atmosphere. So what are the regulations which have been set to control the emission of ozone depleting substances? As per Marpol Annex 6, any deliberate emissions of ozone depleting substances shall be prohibited. Deliberate emissions mean emission occurring during maintaining, repairing, or servicing of system or equipments. The next one is installations which contain ozone depleting substances other than hydrochlorofluorocarbons shall be prohibited on ships constructed on or after 19th May 2005. As I already told you, hydrochlorofluorocarbon has a shorter lifetime than chlorofluorocarbon. In other words, we can also say HCFCs are less harmful than CFCs. But this does not mean that HCFC does not cause any harm to the environment. That is why the next regulation has been set for the control of HCFC as well. So installation which contains HCFC shall be prohibited on ships constructed on or after 1st January 2020. Next, we'll be looking into NOx. NOx are nitrogenous oxides which include nitrogen oxide, nitrogen dioxide, and other oxides of nitrogen. The major source of NOx emissions are high temperature combustion process. These nitrogenous oxides contribute to the formation of acid rain. So let us see to which ships NOx regulations apply to. NOx regulation apply to each marine diesel engine with a powerful output of more than 130 kilowatts installed on ships. It also applies to each marine diesel engine with a powerful output of more than 130 kilowatt which undergoes a major conversion on or after 1st January 2000. Next thing is the NOx emission control area. These are certain sea areas where there are more stringent regulations for control of emission of NOx. First is the North American Emission Control Area, the United States Caribbean Sea Emission Control Area, the Baltic Sea Emission Control Area, the North Sea Emission Control Area. The last two that you see in blue are for ships constructed on or after 1st January 2021. This is the table for NOx emission limits. This table is divided into three tiers, Tier 1, Tier 2 and Tier 3 as per the construction date of the ship, and the NOx emission limits are given in gram per kilowatt hour. This N which you can see here stands for engine RPM. Now first look at Tier 1. Tier 1 applies to ships constructed on or after 1st January 2000. When engine RPM is less than 130, then NOx emission limit is 17 gram per kilowatt hour. If engine RPM is between 130 to 1999, then there is a formula given for calculating the emission limit, which is 45 into n to the power minus 0.2. And when the engine RPM is 2000 or more, then the emission limit is 9.8 gram per kilowatt hour. Likewise, Tier 2 applies to ships constructed on or after 1st January 2011. So for engines with RPM less than 130, the NOx emission limit is 14.4 gram per kilowatt hour. For engines with RPM 130 to 1999, the formula is 44 into engine RPM to the power minus 0.23, and for RPM of 2000 or more, emission limit is 7.7 gram per kilowatt hour. Tier 3 regulations apply to ships constructed on or after 1st January 2016 which are operating in a dedicated NOx emission control area. So as you can see, the emission limit has been further reduced from 14.4 to 3.4 gram per kilowatt hour, and for RPMs 2000 or more it is 2.0 gram per kilowatt hour. So as you can see in this table, NOx emission limits are reducing as you go down in the table. This clearly shows that a lot of steps are being taken to reduce the NOx emissions from ships. Next up is SOx or sulfur oxide. Sulfur oxide gases are formed when fuel containing sulfur is burnt. The main sulfur oxide gas is a colorless, non-flammable gas with a penetrating odor that irritates the eyes and air passage. The SOx and particulate matter emission control applies to your fuel oils, combustion equipment which are present on board, including your main engines, auxiliary engines, together with boilers as well as inert gas generators. Now let us look at the SOx emission control areas: the North American Emission Control Area, the United States Caribbean Sea Emission Control Area, the Baltic Sea Emission Control Area, and the North Sea Emission Control Area. You must have noticed that SOx and NOx emission control areas are the same now. It is because of the two new areas which have been added in NOx emission control areas, as you have seen earlier. Now let us look at the SOx emission limits. The left column is for ships outside an ECA, and the right column is for ships which are inside a SOx emission control area. So first let us look at the left part when the ship is outside an ECA. Before 1st January 2012, the sulfur emission limits were 4.50% mass by mass. After 1st January 2012, these limits were reduced to 3.50% mass by mass. And after 1st January 2020, these limits are further reduced to 0.5% mass by mass. Now this side is for ships which are inside a sulfur emission control area. Before 1st July 2010, the sulfur emission limits were 1.5% mass by mass. After 1st July 2010, the reduced limits were 1% mass by mass. And after 1st January 2015, the sulfur emission limits were further reduced to 0.1% mass by mass. So as you can clearly see, the SOx emission regulations are becoming more stringent as the time passes by. So there are commonly two ways by which ships reduce their SOx emissions to comply with these set regulations. First is changeover of fuel. Before entering SOx emission control area, ships change over their fuel oil which they are presently using to a lower sulfur fuel oil to comply with the emission limits in an ECA. Another way to reduce sulfur emissions is the exhaust gas cleaning system, or commonly known as the scrubber. As the name suggests, the exhaust gas cleaning system cleans the exhaust gases produced after combustion of fuel and therefore reduce the sulfur content in it. Next thing that we are going to discuss about is the volatile organic compound. VOCs or volatile organic compounds are organic chemicals that easily vaporize at room temperature. This regulation only applies to tankers and also gas carriers only if the type of loading and containment system allows safe retention of VOCs on board or their safe return ashore. These volatile organic compounds are generated during combustion, but mainly on ships. Its main source is during handling of oil products. VOC emissions occur during loading of liquid cargo in oil tankers in the form of hydrocarbons. Also during voyage, additional gas may be released from the cargo which is loaded and therefore emitting VOCs. So there are certain steps which are taken to reduce these VOC emissions on board. To reduce the volatile organic compound emissions on board, a vapor emission control system is installed on ships as well as the terminals, and ship and terminals work in accordance with the standards set for the vapor emission control system. Also, it is required that crude oil tankers shall have a approved VOC management plan which is ship specific. Now moving on to IAPPC, IAPPC stands for International Air Pollution Prevention Certificate. All ships of 400 gross tonnage and above, every fixed or floating platform and drilling rig shall be issued with an International Air Pollution Prevention Certificate. It is issued by the administration after an initial or renewal survey. In addition to the regulations that we have discussed till now, there are some energy efficiency regulations which have been set up to promote sustainable shipping. The EEDI, or the Energy Efficiency Design Index, reflects the amount of CO2 which is generated per ton mile. It aims at promoting the use of more energy efficiency equipment and engines. Next is SEEMP, which is the Ship Energy Efficiency Management Plan. The SEEMP is a system which is established to improve the energy efficiency of a vessel in a cost-effective manner. Next thing is International Energy Efficiency Certificate. The IEEC is a certificate which covers both the SEEMP and the EEDI. This certificate is valid for the life of ship unless the ship undergoes a major conversion, a change of flag, or it is withdrawal from its service. By this we come to an end. I hope this video helps you in many ways.